Hello, everybody. Thank you for coming. I'm Sadik, working in Arm NN product, coming from Galway, Ireland. I'm here with my colleague, Jim. So I'm going to talk to you about the Arm NN 1908 release and what kind of improvements we implemented. Quick, brief outline. It's going to be first, I'm going to give the quick overview of Arm NN product. And I'm going to talk to you, after that, I'm going to talk to you about the new feature we introduced in dynamic backend loading. But during this session, I'm also going to touch the backends in Arm NN, what they are for and how it works. After that, I'm going to talk about the new operator support we added to the Arm Android NN HAL driver, and we also added some improvements for the existing operators. Later on, I'm going to talk about the ongoing work we are doing on external profiling. Arm NN overview. Arm NN is an inference engine for CPUs, NPUs, and GPUs. It bridges the gap between the existing neural network frameworks and underlying IP. It enables the efficient translation of existing neural network frameworks such as Caffe, TF-Lite, TensorFlow, and allowing them to run efficiently on underlying IP like ARM Cortex-A CPUs, Mali GPUs, or ML processors, ARM ML processors. Latest release of ARM supports Caffe, TensorFlow Lite, and Onyx. Arm NN takes networks from those neural network frameworks, translates them into the Arm NN internal format, and through the compute library, deploy them to the underlying IP. Also available in Arm NN API HAL driver, which is an API for Google's interface that accelerates the neural networks on Android devices. By default, NN API runs the neural network workloads on devices' core CPUs, but at the same time, they also provide the hardware abstraction layer that can target the other processors on the devices. So Arm NN provides the Arm NN HAL driver that forwards the NN API calls to the Arm NN, which can target the other underlying IP. Arm NN provides the backends for the lower level libraries. I'm going to touch the backends on the next slides. As you can see, currently Neon backend, CL backend, and Reference Backend available in Arm NN. New backends can be added to the Arm NN by pluggable backend mechanism. And within the new feature, we introduced 1908. Also, dynamic backend loading is available in Arm NN right now. Some applications, some neural network applications, can use the compute library directly. It's still available. And Arm NN is only inference only. Training is not supported. Arm NN is a C++ 14 ML inference API for Linux. It's developed as an open source software. Contributions are all welcome from anyone, and they are reviewed before acceptance. Arm NN has a synchronized release for with compute library and Android NN API driver libraries. I put some useful links for anybody interested in the Arm NN source code and information. It's a review.mlplatform.org. When you check the projects, there's Arm NN compute library and Android NN driver all there. Also, we have a website, mlplatform.org. You can find some blogs, information about how to contribute to Arm NN, and all other how-to guides as well. Dynamic backend loading. Before going to the new features, I wanted to touch the backends in Arm NN. Backend is an abstraction that maps the layer of a network graph to the hardware that is responsible for running those layers. Backends support one or more layers from the graph, and backend create the backend specific workloads for the layers they support. And each layer will be executing using a workload, and a workload is used to enqueue a layer for computation. Backends execute the workloads they create. As you can see from the source tree, backends resides under the Arm NN source backends in the separate subdirectories. As I mentioned earlier, currently we have CL, Neon, and Reference Backend. I'm not sure it doesn't show all the three there. And also, it's available right now. The custom backends can be added to the Arm NN by pluggable backend mechanism. As you can see in the blue there, my backend is the custom. It's an example of the custom backend. You create the directory, you add your make files and source files. The important thing in here, you need to be careful about your backend ID. Your backend name should be unique amongst all other backends. There was a presentation about the pluggable backend mechanism on the previous Linaro, and then there were slides, documentation, and slides should be available on the Linaro website, Linaro Correct website. Dynamic backend loading, this is a new feature we introduced. It enables Arm NN to discover all the backends available on a system, dynamically load any it can find during the runtime startup. So within that, it allows to have the statically linked backends and or dynamically loaded backends in the Arm NN. For Arm NN to handle it correctly, the dynamic backend object must expose the following interface. It needs to have a unique ID amongst the backends. It needs to indicate a version, and it needs to return a valid instance of the backend. A list of absolute paths can be specified at the compile time by setting a defined name, dynamic backend paths, as you can see from the example. And Arm NN will scan through those set of paths, searching for suitable backend objects to load any during the creation of the runtime. These paths can be overridden by setting the value of the m_dynamic backends path member in the creation options class. But only one path is allowed to override via this option. And if you choose this option to override the paths, all the list of paths with the compiler directive, it's going to be ignored by the Arm NN, and it's going to be the dynamic backend loading is going to use the value which is set for the m_dynamic backend path. There's a naming scheme for dynamic backend object has to align with, which is vendor_name_backend.so and version. There's an example there, Arm GPU _backend.so or Arm GPU _backend.so.1.2.3. Symlinks to the other files are allowed to support the standard Linux shared object versioning, as you can see from the slide. To be loaded properly, a dynamic backend must declare a version that is compatible with the Arm NN backend API. And to be guaranteed that a a backend is guaranteed to be compatible when it has been compiled with the same major version of the Arm NN backend API and equal to or greater than the minor version. For example, if you look at the slide, dynamic backend version 2.4, it's built with the backend API version 2.4. It's compatible with the Arm NN's backend API 2.4. And dynamic backend version 2.1, it's compiled with the backend API version 2.1, and it's compatible with the Arm NN's backend API version 2.4. But dynamic backend version 2.0, it's compiled with the backend API 2.0, is not compatible with the Arm NN's backend API version 1.0. Backend requires a completely new API version, or it needs to be compiled with the newer version. Arm NN will try to load the dynamic backends in the same order as they are passed from the file system. A dynamic implementation of the reference backend is provided in the source code under the Arm NN source backend dynamic, and then we create the reference, and then cmake list.txt is the used for building the reference dynamic version for that, and then the source files are the ref dynamic backend.cpp and hpp files. We also provided the mock dynamic backend for the testing purposes under the backend's common test dynamic backend. Much more information can be found in the README file on the under the backend source tree. Arm Android NN HAL driver. As I mentioned earlier, HAL driver, it forwards the NN API HAL calls to the Arm NN. We added the support for Android Q FSK-2 tag name. And at the moment, Arm NN supports Android P and Android Q. We added new operator supports like maximum, minimum, path, version 2, p-value, resize by linears, paste to depth, quantize, dequantize. And we also added we improved some of the operators. For example, we added the dilation support for convolution 2D and device convolution 2D during this time. In total, about 40 operators supported in Arm Android NN HAL driver, and it's growing at the moment. And if I go to the next one, this one is ongoing work, external profiling support. The main purpose of this work is provide a good integration with the Arm Development Studio tool and streamline so that profiling information can be visualized in Streamline with enhanced machine learning awareness. As the first phase, we concentrated on providing the infrastructure for communication and exchange of counter metadata values and processing of SAN counter metadata and stop-start counter collection commands from the Arm Development Studio. So this is an ongoing work, and we are hoping to finish this work at 1911 release to provide. It's supposed to be my final slide, but I wanted to go to ArminnQuantizer Application. So ArminnQuantizer Application introduced in 1902 release as providing the static quantization based on rules. It involves rules based on layer type and some default values for those layers. But later on, within the 1905 and 1908 release, we added new functionalities to the Arm NN quantizer tool. First of all, we introduced a new data type to Arm NN, which is quantized SIM16 data type. So before, you could only convert FP32 to quantize a SIM quantize a symmetric 8-bit data type, but right now you can convert it to the quantize symmetric 16 model data type as well. We also introduced the dynamic quantization into the ArminnQuantizer application. Dynamic quantization involves running a large set of data through the model in FP32, and at each intermediate tensor, storing all the maximum and minimum values for over all the data set run through the network, and then you have a really dynamic calibration of data set, and then you can calculate the exact quantization parameters for each tensor at the stage of the model. So there are new options we added, which is the CSV file, which is your data input, which is gonna CSV file containing paths for raw input tensors, infant tensors data. We also introduced the scheme as a new data type support is added to the quantizer. And also we introduced the preserve data type option that indicate whether to preserve the input and output data type, as quantize and dequantize operators are supported in the Arm NN. You can preserve the input and output layers in the model, and the Arm NN is going to add the quantize layer after the input and dequantize layer before the output layers. Yes, and then next one, building those applications, building the Arm NN quantizer applications, you need to change the options in the global config CMake file, which is Arm NN quantizer. It's off, it needs to turn on in the global config CMake file. And it's the same as for the Arm NN converter. Arm NN converter, it takes the model and converts it, serialize it to the Arm NN model format. The next one is the reference backend. Before 1908, the reference backend was built automatically, but within the 1908, we made it optional. So the reference backend can now be built optionally as all other backends. It's enabled by default in the global CMake file at the moment under the Arm NN CMake global config.cmake. To enable or disable it, through the CMake options, you can add -d Arm NN ref equals 0 to disable it, or to disable or enable it permanently, you can just change it on the global config.cmake file. To disable the reference backend, disabling the reference backend will impact some of the unit tests that are built with Arm NN, as many of them use the reference backend as a way to perform the cross-verification and end-to-end test. Follow the usage of the Arm NN ref through the make files and Arm NN ref enabled in the code to know which unit test may be excluded if the reference backend is disabled. There's more information about it on the release notes and README files. I have a couple of useful links in here as Linaro website for the review of mlplatform.org for the Arm NN compute library and Android NN driver. We also have README files for Caffe parsers. As I said, Arm NN supports the Caffe, TF-Lite, TensorFlow, and Onyx. I didn't put the Onyx ones there, but yeah, it's there. You can have. And thank you very much. Okay, that's all me. Yeah.
For the quantizer, you mentioned some options you
It is, yeah, they're all available there.
And which model do you support? Like you can quantize 32 or
It's quantizer. It's taking the FP2 Arm NN model and it's converting into the Arm NN model.
Whatever 32 or 1x to Arm model first, then to quantize.
Yes. So there's an Arm NN converter. It takes the TF Lite or whatever model. It converts it into the Arm NN format, and then you feed the Arm NN format into the quantizer, and it.
So for the Arm format, do you have like some kind of serialized?
We have, yes, we have it, yeah. I didn't touch them because they were presented before on the previous Linaro, so you know it's. Yeah.
Which of the backends support your new 16-bit quantization format?
Which?
Oh, the backends.
It's up to the backend, so it is at the moment. It's at the moment GPU supports the Open CL backend supports the 16-bit, but not for every operator. So we ask. There's a mechanism in Arm NN to ask the backend if they are supporting on that data type on that operators. And GPU mostly supports most of them, CL backend. Neon, some of them. But we are adding the support for reference backend at the moment.
What is the reasoning behind going for symmetric 16-bit? Is it for accuracy, or is it because some backends support better performance for in 16?
I am not sure about that. Maybe Jim, you have an input on that?
It's for increased accuracy, and it's one of the new formats that Google have brought in the latest release of Android, so that's why we're following it casually.
Yeah. Okay, thank you very much, everybody.